Looking more closely at the first part of the chapter, we examine how to connect a button to a GPIO input pin. As part of this configuration, we briefly discuss using pull-up or pull-down resistors. Finally, we look at the driver lib code that lets us read the data value on the input pin. Before we can read a push-button switch, we first need to connect the switch to a GPIO pin. When using the MSPM0 G3507 launchpad, switch 2 is connected to the PB21 pin. Pushing the button connects the pin to ground. This means that the pin's value will be set to 0. Now, when we release the button, we want the pin's value to go to high to give us a value of 1. But in this example, it will just float. Its signal may go high, or it may stay low. So how can we force the pin to go high? I'm sure many of you already guessed the answer. We can use a resistor connected to the power input rail to pull it high. In this example, the pull-up resistor keeps the line tied high. In other words, with the switch open, the pin will read as a high value. That is, 1. When the switch is depressed, the connection to ground overrides the weak pull-up resistor and changes the pin to a low value, 0. As a side note, in the second part of this chapter, changing a pin's value from high to low can be used to trigger an interrupt. Conversely, when the switch is released and the signal goes back to high, the low to high transition can also be detected by the MCU as an interrupt. But since pull-up resistors are so common in these types of circuits, TI included them for each GPIO pin. You just need to enable them if they are needed in your design. Now that we have seen how valuable the internal pull-up or pull-down resistors can be, how do we enable them? Remember the pin CM registers that we introduced in the previous chapter? These registers allow us to enable or disable the pull-up or pull-down resistors. Looking closely at the datasheet, we can find that the pin CM49 register controls the PB21 pin, which is connected to the push button on the MSPM0 G3507 launchpad. Notice that the driver lib API contains a set of functions to create or edit the pin CM registers. But if you are using the system configuration tool, you will probably never need to use this API function. Let's go back and have another look at the pin CM register bit fields. Notice that 2 bits control the pull-up or pull-down resistors. Combining this with the GPIO driver lib function, we can change the resistor setting using the line of code found on the next slide. Here is an example which utilizes the driver lib library to enable the internal pull-up resistor. Notice how driver lib provides the symbols for the pin CTM register argument as well as for the pull-up resistor. But like we said a minute ago, we do not recommend using the driver lib library for configuring the GPIO resistor settings. What would be a better alternative? If you told yourself that using the system config tool would be a better way to set the pull-up resistor value, you are correct. Using this tool, it's very simple to change your pin's initial configuration. Finally, how can we read the pin using code? From the last chapter, you might remember that we used the data out register to set the value on the output pin. Similarly, there is a data input register that lets us read values from their corresponding pins. Looking at the code, the DL, GPIO, read pins function lets us get the pin's value. Also, please notice the port and pin symbols used with this function. You might remember they were defined earlier when we configured our pin using the system configuration tool. Next up, we take a look at our upcoming lab exercise.